We've talked about the geometrical isomers in the first chapter, in chapter 11. And this is just a revision in there. We said that geometrical isomers, which are cis and trans, those they do exist in cycles and they exist in alkenes. And we said that they exist in the cycles whenever you have only two substituents on the cycle, and then they can exist as cis and trans, cis having the substituents on the same side, whether both they are up or both they are down, or trans having the substituents on opposite sides in there. Now, for cis and trans, those they are included in the name. So if you see two substituents on the cycle, you have to indicate what is the direction of these substituents with respect to each other. Because if you drop the cis and the trans, the substituents, the two methyl groups can either be on the same side or they can be on opposite sides. So you have to really be specific in there. We said that geometrical isomers, these are type of stereoisomers. And we said that you cannot go from cis to trans by rotation unless you break the cycle, twist the cycle, and then fuse it back. So going from cis to trans cannot happen by a simple rotation in there. If you rotated the cis, it will be cis. And if you rotated the trans, it will be trans. The only way you can go from cis to trans is to break the cycle, twist it, and then fuse it back. And this is how you go from cis to trans. And this is why we say that cis and trans are stereoisomers. They are type of stereoisomers. So geometrical isomer is a type of stereoisomer in there. If I have a structure like this, I cannot use cis and trans. So more than two groups on the cycle, please don't use cis and trans. If there are no wedges and dashes shown, don't use cis and trans. So if I have something like this, let's say, for example, if I have a cycle and if I have all of these groups like this here, okay, and that is a chlorine, I have something like this there, or I'm sorry, I meant no chlorine. If I have something like this and there is no cis and trans because I am not showing the stereochemistry of these two CH3s. So the name in there is going to be 1,2-dimethyl cyclohexane. No cis, no trans. So you use cis and trans whenever you have wedges and dashes and whenever you see that you only have two groups on the cycle. If you have more than two groups on the cycle like this one, you cannot use cis and trans. So please do not use cis and trans. The name is going to be as written in there. And you always start by giving the substituents the lowest number. So it makes sense that I'm going to start numbering from this carbon over here in order to give it the lowest number. Same thing, if you have wedges and dashes in there, three substituents, no cis and trans whatsoever. So you are going to name this as 1, 2, and 3. You're going to give your substituents the lowest number. This means that you can either start naming or numbering from this carbon, or you can number from this carbon and both are going to be the same. So that is going to be 1, 2, 3 in there. You're going to end up having the same set of naming. It's a trimethyl cyclohexane. Same thing for this structure over here. You got to give your substituents the lowest number possible, but now here, see the difference. All of them, they are pointing up. So even though I do have three substituents, and this only happens with cis, not with the trans though. So even though here I have three substituents, but all of them are on the same side. So this is the only case where I can use, with this three substituents on the cycle, I can use the cis and the trans. So this is why my name here is going to be cis. 1,3,4-trimethyl cyclohexane. This indicates that all the CH3s are pointing or are being on the same side. Whether they are all up or they are all down, it's the same, guys. It is the same. Cis and trans also exist in alkenes. And we said that in order to locate cis and the trans, all what you need to do is simply highlight your double bond and then see the substituents around the carbons of the double bond and which direction they are. So if they are on opposite sides, then that is going to be trans. These two are the same. They are on opposite sides. Don't forget that you already have hydrogens in here. And when you talk about cis and trans, you would need to compare the groups that are the same, either the hydrogens or the chlorines, it doesn't matter. So I could go with the hydrogens and say that the hydrogens are opposite with respect to each other. So this is going to be trans in there. And then you do have over here the chlorine or the hydrogen on the same side. And this is considered to be cis. So cis and trans, which are geometrical isomers, they exist either in a cycle or they exist in an alkene. Not every alkene has cis and trans. For an alkene to have cis and trans, it needs to have two groups that are the same, and those groups, they need to be on adjacent carbons, whether it's a chlorine, a hydrogen, a bromine, it really doesn't matter, but the groups have to be the same and they have to be on adjacent carbon. If you find an alkene that has two groups that are the same on the same carbon, like something like this here, okay, see, these two hydrogens are the same and they are on the same carbon, then this means that there is no cis and the trans for this one. Same thing, you have the two chlorines that are the same and they are on the same carbon, not on adjacent carbons, on the same carbon, this means that there is no cis and trans. So when I name it, I skip the cis part and the trans part, and I simply name it as a propene here. And this one is going to be a 1,1, it's going to be a dichloro, and it's going to be a propene. Remember, when you name a system of double bonds, you have to give the double bond the lowest number. So definitely I need to start numbering from that double bond in there. Same thing here, it's going to be 1, 2, and 3. So the double bond always gets the lowest number possible.